Our topic today is frequency tables and histograms. Now these are two ways of taking and condensing a display of a group of data, and these two go very nicely together. I want to first talk about the word frequency. Frequency is a word that means how much or how often or how fast. And so right here, these numbers will describe how much of a particular category we have. Our categories are shown over here in the left column, which are, in this case, hours online. Each person spent a certain number of hours online per week. And the frequency simply counts up the number of people in a set of data that fits that category. So this 5 right here shows us that we have 5 people that spent 0 to 3 hours online this week. Here we have 7 people that spent 4 to 7 hours online, 12 people that spent 8 to 11 hours online, somewhere between those, and so forth down the list. The histogram is a type of bar graph that will take that data and display it as a picture. I kind of like how it shows the different shapes. We'll talk about that in a little bit. On the y-axis right here, to complete our bar graph, we have frequency, and that matches the frequency from the frequency table here. So we see that our highest is 45. This y-axis is going to have to go up to 45 in order to fit all of our data right here. So I'm going to go up by 5s here, 5, 10, 15, 20, 25, 30, 35, 40. Up here, let's number that, 5, 10, 15, 20, 25, 30, 35, and 40. And we are going to draw for each of these categories a bar, and the height will indicate the frequency. So right here, in our 0 to 3 category, we have 5. That means I'm going to draw a bar over this 0 to 3 category that goes up to a height of 5. That shows us that we have 5 people in this 0 to 3 category. Some people like to shade this in. Some people leave it open just so long as you can see the height of that bar. It doesn't matter too much. Our 4 to 7 category has 7 people in it, so I'm going to go up here to 7. That'll be a little bit taller. 8 to 11 has 12. So we're going to go up here just a little bit above 10. And we're going to continue to draw bars for each of these. So 12 to 15, we're up to 14. 16 to 19 goes up to 26. 20 to 23 is the one that goes all the way up to 45. I didn't quite make it there, so we'll stretch this out, go to 45. There we go. So up to 45. And then 24 to 27 has 33. So we're going to go here to 33. Okay, so now we can see where people lie. This gives us a nice visual. We can see that we have a large group of people over here. There's a lot of people that have spent a higher amount of hours online, and there are fewer people that spent fewer hours online. So our next question is going to talk a little bit about the distribution of the data, and we're going to have 3 vocabulary words for that, just like with our box and whisker plot. It actually coordinates with those from the box and whisker plot. Our first one is skewed to the left, and you can see that with this graph, there's a tail that points out to the left side. It kind of gets stretched out to the left side. And then we have a hump with the data over on the right-hand side. Our next is symmetric. And you can see right here that the histogram has a shape that is about the same on all sides. So there's a tail on both sides that goes about to the same length on either side. The height, the hump for the data, is in the center of that, and it's about the same on both sides. And our last word is skewed to the right. Similar to skewed left, this one goes off the tail. You can see that the tail is pulled over here to the right, and that gives us the name skewed to the right. And we have our 3 vocab words. There are, of course, some more of these, but we're going to focus on those 3. Let's go back to our histogram right here. We can see this one has the height of our data is over here, and our tail goes over here to the left-hand side. So this graph I would describe as skewed to the left. So you just have to kind of take a look at each of the graph, pay special attention to the tail, whether it's been pulled to the left, pulled to the right, or whether it's symmetric on both sides. Thank you.